So today we released our user survey, which we've been doing every 6 months. And one of the most notable things that we saw looking year over year from 2016 to 2017 is the shift to mainstream industries outside of IT. And one of the industries that had the most significant growth was financial services. So today we're going to hear from Commonwealth Bank, which is one of the largest banks here in Australia. And next up, welcome Quentin Anderson to talk to us.
Thank you. Morning, everyone. I'm head of systems engineering for a part of the Commonwealth Bank called Analytics and Information. The Commonwealth Bank is one of the larger banks in Australia, one of the largest banks in the world by market cap. And the bank's vision is to excel at enhancing the financial well-being of people, communities, and businesses. This, for me, is a pretty awesome vision to get behind. Financial well-being is a vital part of the everyday lives of ourselves and our businesses, and really figuring out what it takes to enhance financial well-being is quite a complex thing. And when you think about all the different aspects involved in doing that, there's quite a few, but the two key areas that I focus on or that I concern myself with are data and experimentation. When you think about what it takes to not only personalize, but fully target and really understand what your customers need, it's very much a data and experimentation exercise. We started down this journey circa 4 to 5 years ago, really trying to mature the way that we approach both management of data and machine learning for that purpose. And if you think about what is the maturity steps that you might go through in order to really have a data-driven and an experimentation-driven organization, you start with the basic process of experimentation, kind of a first level of maturity. You get some data in the correct place, and you start to generate some experiments. And the experimentation process is interesting. You learn a lot, but it's not fundamentally the place you need to get to because experiments are often brittle, very much a scientific process. And so you've got to get to a next level of maturity, which is how do I take those experiments and how do I go from the lab to the factory? How do I get to the state where my experiments result in predictions, result in customizations of the way I engage with my customer and the way my product systems behave in a way that is reliable, operational, productionized. And so that's kind of the second level of maturity, and you spend a lot of time figuring out how you're going to deal with your labels, how you're going to monitor your data, how you're going to monitor your models. The third level of maturity you get to is, well, now you've got some experiments which result in predictions which are reliable, but you've fundamentally got to impact the customer experience and the way the business operates as a result. And we call this third level of maturity decisioning. And so the representation that you see here is what logically what our resulting data environment looks like. So we have kind of two major use cases. The one is this third level of maturity around experimentation and prediction, which we call decisioning. And that's all about closed loop interactions, integrating analytical processes and data management processes into the product systems to impact all kinds of different decisions, what the customer sees when, how we engage with the customer, et cetera. And then on the right-hand side, information for people, which is allowing our internal staff to know what's going on, not only with our business, but with our customers' business and within our customers' lives, and make good decisions in business operations. From a technology point of view, the way we do this is we have some fairly large Hadoop clusters. We also have some fairly traditional data warehousing technology. And the Hadoop clusters, when we started off down this journey, were entirely based on physical servers in our data centers, running RHEL and just installing Cloudera directly onto those servers. And that worked in the beginning, but as you can imagine, comes with a bunch of inherent constraints which we needed to work through. The primary ones, obviously, unit cost, cost of change every time we have to do large upgrades, et cetera, but also the developer experience was not amazing. And so we departed on a journey to try and cloud enable some of these technologies so that the process of experimentation was a lot faster for our business, but also a lot cheaper and a lot more deterministic. So the technology stack that we landed on is not all that unique. It's fairly typical. We've got OpenStack at the bottom, and we run Ironic for that. The reason for Ironic for the initial set of use cases is the big data processing, very much stateful services want to be close to disk. And also, increasingly, as we move into microservices, the VM abstraction is in a lot of ways uncomfortable if you want to drive immutability. On top of that, we run Ubuntu. We use Docker for containers, Calico for container networking. We use Vault for secrets management, and then moving up, we use Mesos and Marathon for resource orchestration and effectively a PaaS API. And on top of that, we run our big data applications and finally end applications on top of that. So this is a fairly typical stack. It's container cluster. It's container cluster on top of a cloud. What we feel like we've done fairly uniquely is we focused on continuous delivery at all layers of the stack. We also focused on versioning through codification and immutability at all layers of the stack. So for us, an upgrade of an operating system or even changing the permissions on a folder inside an operating system in an underlying host is not a matter of SSHing into a box, but rather updating a declarative form of the environment and issuing a pull request and allowing the tooling to make all the changes on your behalf. This is true for operating system, it's true for container, it's true for container clusters, container orchestrators, monitoring, alerting, absolutely everything. We use the same basic interaction pattern, which is versioning through codification, automation through codification, and continuous delivery, applying the changes off the back of that. To go into a bit more detail around how that workflow looks, we separate out a module repository, which has the source code, the tests, the pipeline, the build, etc., for a particular module. A module might be a container within the control tier. It might be an app. It might be anything that's going to be executing inside an environment. And we separate those module repos from our environment repos. And the environment repos contain declarative forms of the environment. It's a fairly common pattern to have declarative YAML or JSON files to define what the environment needs to look like as opposed to what changes you need to apply to the environment. And we try and ensure that these things are strongly versioned. So I have a declarative form of my environment sitting on master, and this represents what's running inside production or inside the designated environment. I fork the repo from that point. I'll make some changes, either upgrading, introducing hosts, deploying new clusters, deploying new applications, and I issue a pull request against the deploy branch. The build tooling will then generate a change plan and attach that to the pull request for me. You can think about this workflow as being pretty similar to HashiCorp's Terraform, where it's going to generate a change plan, but we've integrated this very strongly into GitHub and therefore into version control. So the tooling will go off, generate a change plan for you, attach it to the pull request, describing if you were to merge this pull request, these are the changes that I'd apply to the environment for you. We then have a number of bots, for want of a better word, that will go and do reviews of those changes. Is there enough capacity in the environment? Are you introducing a risky change? Are you deploying into the correct environment? Are you a junior developer and therefore you shouldn't be pulling against production, so forth? And so there's a bunch of automated checks that take place at that point. There's also a bunch of manual checks because it's a pull request. Humans go and take a look at the proposed changes. When the pull request merges, the tooling goes off and applies the changes into the environment. And so you can think about what's sitting on the deploy branch as being effectively the desired state, what's sitting on master as being the actual state or the previous state. And the tooling is going to go off and apply those changes to the environment by making API calls to Nova or to Marathon, HashiCorp Vault, so forth. And once the changes have completed, it will then merge the new declarative form back onto master. And so you've got desired state, you've got actual state, you've got an interim desired state convergence, which are in your logs. And when you get failures in the deployment, it's fairly easy to debug from that point. Of course, as you do smaller and smaller changes, that problem becomes less and less. So when you think about this, what we land up with is various types of composition that are going on. And what we've done in this overall stack is that we've composed a rather large number of open source projects together in order to generate our business outcomes. And when you think about the type of composition that you're doing, there's build time composition. I'm bringing two libraries together and I'm putting them into a Docker container or into a jar into a Docker container. I'm doing deploy time composition, something like sidecarts. And I'm also doing runtime composition. I've got microservices and APIs and they're interacting with each other. And we believe strongly that versioning through codification gives us an absolute base case to be able to change all of those different levels of compositions and therefore services and systems in a sustainable manner over time. Because it allows us to recreate environments, it allows us to build automation in a scalable manner, and it allows us to recreate environments and therefore have automated testing, which is the basis on which safe change can take place. So with that in place, or with those basics in place, there's a fair number of open source projects that we've worked towards, that we've integrated in order to achieve some of the outcomes we have. So we started with OpenStack as being the basis for this approach, and in order for you to even just do immutable and codified access of your infrastructure, OpenStack, ironic, is the first place you start, and then it's a build-up from there. Over time, we're moving the same approach over into our public cloud environments, because we very much have a hybrid cloud strategy. If you take then from the top down, software supply chain management, Jenkins, Notary from a trust point of view, and various tools, OpenStack being an example, but lots of others in the supply chain management side of things, which are all part of pipelines, but enforced through the codification approach I described. In the analytics space then, R is a major tool of use from our data scientists, and Hadoop, increasingly Spark as a part of the Hadoop ecosystem. We still have a fair amount of HDFS from a stateful workload perspective, and increasingly Cassandra. And starting small, but an increasing amount of TensorFlow coming in. Going down the next level, I've mentioned Vault a few times. We use Mesos primarily in the stateful space at the moment, and increasingly in the stateless space, Kubernetes. Calico gives us the container networking. Calico's got some nice aspects in that it's simple, but also it integrates really nicely with existing networking environments across the different cloud providers. And we use Docker as our containers, and Ubuntu as the hosts across the different cloud providers. This provides us not only a nice environment for our stateful and our analytics workloads, it also increasingly is providing us with a nice environment to host different types of workloads, pure microservices. It started with just data science dashboards, Python user interfaces, Python dashboards, R Shiny, etc., and increasingly is going into our more web-facing workloads and microservices. It's been a really interesting journey to start with composing OpenStack in some basic container environments and work through the entire process of composing the rest of these open source technologies using a strong approach of getting the basics right first. Thank you very much for your time.
All right, thank you, Quentin. We appreciate it. I mentioned earlier that financial services is one of the fastest growing industries that we have, and I wanted to highlight another group that is kicking off this week, which is the financial services team. China UnionPay is actually one of the founding members and helped get this started, along with help from Intel and SUSE. So if you have an interest in financial services, please join that group kicking off this week. And we're also going to hear from China UnionPay about their story, as well as Insurance Australia Group. So some great sessions coming.